Okay, yesterday we went over measuring practice and we talked about significant figures. I did add this place value chart for you all. So let's look at where the number 1 is. Here it's in the ones position. If I make it to a more precise value, that would be the tenths. The smaller I go, the more precise that measurement is. That's the hundredths. If I go the other way, this one is in the tens position, this one is in the hundreds position. Notice this is hundreds and this is hundredths, hundredths. Okay, so I had you do 2 on your own. The first one I had you do on your own was this, number 4. We read the meniscus at the bottom, and it is between 24 and 25, so I know 24 for sure. And then I'm going to make my best guess between 24 and 25. That would be guessing at the tenths position, and I've guessed 24.5. If you guess 24.6, that would be fine. Every number I know for sure plus my one estimate is considered significant. That's all those numbers. I have 3 of them. And my 0.5, which is the smallest place value I have there, is the tenths. So I measured, my precision was to the tenths there. That's what I measured. Okay, so let's go to our next worksheet, and I'm going to get rid of that right now. We did these 2 rulers together, and now this ruler, it's between 4,000 and 5,000, so I know 4,000 for sure. That's my thousandths position, so my guesstimate in between can only be one place value down, so I'm going to guesstimate the hundreds position, and I'm going to say that's a little over 500, so I'm going to guess that's 600. You may guess 500. Again, it's a guesstimate. And I cannot estimate the tens. I don't know if that is 4,610, 4,620. It's way too small to see. So the number I knew for sure was my 4,000. I estimated the 600, so I have 2 significant figures. I cannot estimate the tens or the ones. That's much too small. So to what precision did I measure? That's your known value plus your estimate. So I measured to the hundreds position, or the hundreds place. Hundreds. Okay, so that is a review of the worksheet we did yesterday. So now let's go over how to figure out these significant digits from numbers where we don't see the measuring device. So we're talking about measuring precision and significant digits here. So why does it matter? Well, the first reason it matters to chemists is that the more precise we measure, the more expensive that instrument becomes. It's harder to make, it's more detailed. This one measures to the tenths, and it's roughly $300. This computer right here measures to the hundredths. That's 0.00, that's our hundredths, and that's around $1,400. This one measures to the thousandths, 0.000, your thousandths, and now we're up into the $2,400 category. So this becomes very important to any kind of scientist. They want very precise measurements. Also, sometimes we're working with very, very small quantities, so we have to be more precise when we measure those. So just a review. Here is 3 rulers that become more precise, and you can see it in the measurements. This measures to the tenths, that measures to the hundredths, and this one measures to the thousandths, and this would be a much more expensive ruler. So how do we know how precise our measuring equipment is when we don't see the numbers? how do you know which numbers are significant? Well, we're really talking about any non-zero number written was measured or estimated and is significant. So when we did our rulers, you could see that we wrote down all our numbers plus our best guess. So if it is a non-zero number, it is definitely significant. But not all non-zero numbers are significant. Some are just placeholders, and that's what we're going to learn about right now. Okay, there's two categories of numbers to look at. There's numbers without decimals, 1,000, 230, 125. Notice there are zeros at the end here. But let's look at this 1,000 and let's look at this 1,000. Our first 1,000 doesn't have a decimal. I was only measuring to the thousands place. This decimal tells me I measured all the way down to the hundredths place, so this was a much more precise instrument. Okay, so when we have a decimal, we can get to even smaller place values, or we can get more precise, if you want to say it that way. Okay, so Ruane's methods for determining significant figures. You're going to look in books and you're going to see sometimes 5 rules. Zeros to the left of the non-zero numbers, never significant. Sandwiched are significant. Leading zeros, trailing zeros, and there's all these different rules. I find them confusing. I just have one question to ask yourself and 2 things to do. First, you underline the first non-zero number, okay? And then ask yourself, is there a decimal? If there is a decimal, the first number that you underline plus everything to the right counts. So I've underlined my first non-zero number. Notice right here, I'm all the way to the hundredths place, and that's my first non-zero number, and everything to the right counts. So that would be 2 significant figures. Here, the first example, that was 6 significant figures. Again, underline the first non-zero number. If there's a decimal, everything to the right counts, whether there's zeros or not. I don't have anything after this 1 in the tenths position, so that's only 1 significant digit. Okay, now, what if you ask yourself, is there a decimal? And you say no. Now I still first underline the first non-zero number. If there's not a decimal, I underline the second non-zero number, and everything in between counts. So right here, this is 3 significant figures. Here, I underline my first non-zero number. My last non-zero number is this 3 over here. Even though there's still numbers after it, it's my last non-zero number. Everything counts in between it plus my underlined number. So that's 4 significant digits. Notice here we did not measure all the way to the ones position. Our last estimate was in the tens position. Here's the number 3,000 without a decimal. So I underline my first non-zero number, and the last non-zero number is that same number. There's only one number underlined. There's only 1 significant digit. Because there is no decimal, it's showing me that my equipment only measured to the thousands position and was not very precise. So let's do some examples. So I have 300 here, and I'm going to always underline my first non-zero number, and then I'm going to ask myself, is there a decimal? No, there's not a decimal. So I underline my last non-zero number, which happens to be the same number, and everything that's underlined plus what's in between it counts. There's only 1 number underlined, so I only have 1 significant digit. Here I do have a decimal, but I always start by underlining my first non-zero number, and then I ask myself, is there a decimal? There is a decimal, so my first non-zero number and everything to the right will count. So I have 1, 2, 3, 4, 5 significant digits. That's 5. Here is another number. Is there a decimal? There's not, but I always start by underlining my first non-zero number. There it is underlined. And if there's not a decimal, I underline my last non-zero number. There it is. and then everything that's underlined plus the stuff in between counts. So I have 4 significant digits. And here's where they're talking about trailing zeros without a decimal don't count. Okay, here we have sandwich numbers, but there is a decimal, they count. Sandwich numbers, they count. There is no decimal, so the trailing doesn't count. These are those rules that become very confusing, but if you just underline the first non-zero number and then ask yourself, is there a decimal or not, it becomes much easier. So here I have 3/10, and here I have 3/10 as well. What's the difference? Well, there is a decimal. I always underline my first non-zero number. If there's a decimal, everything to the right counts. There's nothing to the right, so I only have one significant figure. Here's 3/10 again, but as a chemist, I can see right away this equipment was much more precise. It measured all the way down to the thousandths position. And if I just use my rules, I can find that out. I underline my first non-zero number and I ask myself, is there a decimal? Yes, there is. So everything to the right is going to count, which means I have 1, 2, 3 significant digits. There we go. So now, here's where a lot of people get confused. Remember, you always underline your first non-zero number first. If you do that, you won't make a mistake. And my first non-zero number is all the way into the thousandths position. So there we go. My first non-zero number. Is there a decimal? Yes, there is. So that number plus everything to the right counts. And I have one more spot to the right. And that means I'm in the 10,000ths position for my precision, but I still only have 2 significant digits. These guys are just placeholders. Okay, so we have one more thing to think about. What do we do if a 0 is significant and you can't use a decimal? So here in this example, we want to show that this number is to 2 significant digits. Right now, without a decimal, it only has 1 significant digit, first non-zero number. If we put a decimal here, it's our first non-zero number, and everything to the right counts. So that would be 4 significant digits. So, but sometimes we only measure to the hundreds, and we want to show that. So how do we do that? We put a line over the 0 that is significant, just like that. So now we have 1, 2 significant digits, and that line shows us where we're going to stop counting.